Good morning. This is your Stat Sensei, Mr. Spensei, and this is an exit ticket on a chi-square. So, first scenario, it's your birthday. And we went through this, and it said while conventional wisdom suggests that births should be uniform throughout the year, some medical professionals speculate that factors such as seasonal conception trends, holidays, and healthcare access may cause fluctuation in birth rates. To explore this, a group of public researchers collects birth records for 1,220 randomly selected newborns. All right, so here we have a single sample from hospitals across the country. And it says, answer the following in space. How many samples are there? Well, there's one. We have one sample of 1,220. How many variables? We have one variable, and that's months. So, and that has 12 levels. And the 12 levels are the months of the year. All right. Then it says, which month had the greatest contribution? Justify your response and show how the calculation for the contribution. Before I do that, I want to point this out. One sample, one variable. If it's one sample and one variable, that can only be a chi-square goodness of fit test, which is what we ran when we did this. All right. So I had all this information in stat edit. I'm going to go stat test chi-square goodness of fit, degrees of freedom 12 minus 1, and I calculated it, and I get my contributions. So that's a 0.02. This is a 1. This is a 3. This is a 0.1. So far, 3 is the biggest. 0.6, 2.7, 0.4, 0.68, 5.3. Ooh, that's a big one. All right, we'll have to figure out what that one is. Oh, here's a 4, but it looks like 5 is going to be my biggest. So this is December. This is January, no, November. This is October. 5 happens to be at September. So September is my largest. It's the largest one. And how did we calculate that? So September had the largest contribution of 5.3551. Well, remember, it's observed minus expected. Well, we observed 125 and we expected 101.6. So let's check that out to make sure that that really worked out. So parenthesis 125 minus 101.667, close it, square it, and then we're going to divide it by 101.667. And sure enough, we get it within rounding error. All right. So we got it within rounding error. So that's how that was calculated. All right. The next one. Well, that was the other scenario, which was fake news. And it says, with concerns about misinformation rising, a journalism class investigates whether, and they had a random sample of 600, so one sample. And the question they ask is, answer the following. How many samples are there? Well, there's one. There's one sample of 600, and list the variables. When I list the variables, we go, okay, is there a relationship between social media platform and news source? So our two variables. So we have one sample, two variables, and because of that, this has to be a chi-squared test of independence. So chi-squared test of independence because one sample, two variables. Well, we had social media platform. That was one variable, and it had three levels. It could have been Facebook, Instagram, or Twitter. And then we had news source, and it had three levels: TV news, online news, or social media news. All right. Appreciate you watching. Look forward to seeing you on the next one. I sure hope this was a help. Thank you.